What is function? Function can be thought of as a box that takes an input and produces an output, depending on the input, of course. So, for example, we can consider it as a kitchen that takes foodstuff as an input and produce processed food, cooked food as the output. So if I represent that function with this box that I've drawn right here, this would be my input and this part would be my output. The box itself becomes the function. Now, if this system that I've drawn here is a function, then it needs a certain rule that it will follow to produce the output from the given input. So there has to be some kind of rule that the input would be processed according to produce the output. Now that rule can be in any form. It could be in the form of algebraic expressions, operations on it, subtractions, additions, multiplication. It could be a statement defining how it should go about producing the output from the input. Relating this to the kitchen, we can say that if foodstuffs are sent to the kitchen, this foodstuff could be boiled, spices could be added, salt, stuff like that. It could be added before a processed food will be produced. So the addition of these spices, boiling it, adding water to it, whatever, frying the food, all these constitute the rule that would act on the input to produce this output as food. Let's consider a function represented by this yellow box. This function takes in an input and produces an output, as shown by the arrows. So let's assume that the rule of this function is to multiply whatever that is given by 2. So let's write a little times 2 here. If I give this function a 3, it will multiply this 3 by 2 to produce a 6. So the 6 here becomes the output of 3. If I give this function a 4, it multiplies this 4 by 2 to produce an 8 as the output. So 4, when you pass 4 through this function, you get an 8. Pass 3 to the function, you get 6 as the output. Let's consider another function represented by this box. In this case, we are not going to consider anything that was going to do mathematical operations on the input, but instead, let's say it takes a letter of the English alphabet as input and it produces an output based on the rule that for every letter given as input, it should produce the next letter of the alphabet as output. So for example, if I give A as input, this function should produce a B as the output. If I give an E as the input, it should produce an F as the output. If I give a G as the input, it should produce an H as the output. Now let's go back to the function that we just represented with this box, where we said that it takes in the input and multiplies that input by 2 and produce the result as an output. This function can be represented in terms of algebraic expressions, as if we call this function f, then we can say that the f is the function name, and we write in parentheses an input variable, just a variable to represent the input, and then we equate this function to the rule or the rule guiding the output production with the input. So in this case, we're multiplying the input by 2. So if f is the function name and x is the input, then the output will definitely be 2x, or in the rule will definitely be 2x. So essentially, this f right here is the function name. This x represents the input, and the 2x right here represents the rule. And in this case, if you evaluate this expression, you should get the output for a given input. Now that we've learned how to represent functions algebraically, we can now look at functions. So let's say a function with the name g defined on the variable a has the algebraic expression or the rule that we are talking about as maybe 3 times of a. Then we can say that if this g takes an input of 2, it should produce an output of 3 times 2, which should give 6. If this gene takes an input of 7, it should produce an output of 3 times 7, which is 21. And as we said earlier, this 6 and this 21 right here represent our output, and then the A right here represents the input. Alright, so far we understand how functions work. We said we can represent them with a box that takes an input and produces an output based on this input. So there has to be a rule that this function will follow to produce the output from the input. Also, we understand that this function can be represented algebraically, writing the function name as, let's say, f defined on an input variable, let's say x, to be equal to the rule. So if you take the first example that we did, we can say 2x, since it multiplies the input by 2. Formally, a function can be defined as a relation existing between two collections of elements, such that for each element in the first collection, there exists exactly one element of the second collection. And it's important that we consider this ending part of the definition, such that for each element in the first collection, there exists exactly one element of the second. So right here, we can see that for this diagram, this relation over here, each element in this first collection is having only one element in the second. It's associated with only one element of the second collection. KNS is associated with only Ashanti region. UHAS is associated with only the Volta region, and Keta SATS is only associated with the Volta region. But for this second diagram, it's not a function because, as we can see, Keta SATS is associated with both Volta region and then the Ashanti region. And for that matter, it violates this part of the definition that stresses the fact that for functions, each of the elements in the first collection should have only one element in the second collection associated with it. Further explanation of what this definition implies and what it does not will be considered on the next slide. Let's get into that. Now, it is important for us to note two major things about the definition of functions that we just looked at. First thing to note is that a function can have more than one input evaluating to the same output. For example, let's consider this function right here, s of a to be equal to a squared. This squares the input. This squares whatever it's given as the input. If I give this function a -3, squares a -3 and produces a 9 as the output. If I give this same function a 3, squares that 3 and produces the same result, 9, as the output. So for this reason, it is important for us to know that a function can have more than one of its inputs evaluating to the same output. Now, the second thing to also note is that functions should have only one output for a given input. If I give the function one input, I expect one output to come out. I don't expect a function to produce more than one output for one given input. Alright, so in conclusion, in this video, we looked at trying to represent functions with boxes so that we kind of understand how functions work by taking input and producing output based on that input. And for that matter, there has to be a certain rule that the function will have to follow to produce the output based on the input. We also looked at representing functions with algebraic expressions, as I've done here. U of t is equal to 2t plus 5. So basically, the u over here represents the function name, the t is a variable representing the input, and then this is kind of the rule that is used to produce the output. So if you evaluate this for their specific input, you should get the output. We also looked at a more formal definition of functions, where we said that function is the relationship between two sets, an input set and an output set, and we said that for each member in the input set, there should exist only one member of the output set associated with it. And we also looked at what this definition implies and does not imply, and all of that. It's very important for us to take note of those two things. And yeah, that's it for this tutorial. Thank you for watching. If you enjoy, I'm glad. I'll see you in the next one.